Marissa mentioned, as Marissa mentioned, so I'm Michael with the Office of Emerging Technology in Boston, and I'm joined by our CIO, Santi Garces. And I'm just going to kick it off to Santi to get us rolling. So Santi.
Yes. So again, thank you for joining us. Buenos dias, bom dia to everybody who's participating. So we wanted to share with you how we're using data and artificial intelligence to improve some of our city services. I think one of the areas where we've been focusing a lot of work in the past year plus has been in thinking about how we can leverage generative AI, some of these set of technologies that allow you to generate text, images, voice, videos out of these like models that have been trained with massive amounts of data. And I think that although the artificial intelligence and machine learning has been around in government, and in fact, I would say everybody in government has probably been using it. If you have any sort of network management tools, security tools, search engines, you've been using probably some form of machine learning, even if you didn't know it. But to the next slide. One of the things that we really started to frame our thinking when this technology with generative AI became available in November of 2022 was, what are the things that would give us pause? What are the things that would make us be concerned about the use of these technologies, and what are the things that we value? What would we have loss aversion? What are the things that we would be averse to losing, and what are things that we would want to stay away from? And again, we started to think about unintended consequences. Like government delivers critical, important services, and we want to make sure that we're being responsible. The worst of things that could happen is we lose trust, right? Most of government relies on trust. We rely on people behaving and doing things according to what we ask them to do or what we expect them to. Wasting time and money, environmental costs, and Michael will share more about that. And on the other side, we thought, what are those things that we're trying to strive towards? So people, transparency, managing innovation and risk management. So also thinking about when there's new tools, there's also opportunities for value, that it is our job in the public sector to try to understand and to try to get that value, even when at first it might feel tenuous, or it might feel that it is the delivery of value might be a little bit inconsistent. So that's what we were trying to wait against. And in about a year ago, we issued guidelines on the use of generative AI for our employees. And fortunately, we're one of the first cities I think in the US and in the world to issue these guidelines. And what we wanted to do is get in a mindset of responsible experimentation in a collective space. So a lot of times we think innovation happens in teams that are dedicated to do innovative things. And we thought it's going to be impossible for us to assess what are the value, what are the use cases that these tools could have, unless we opened them up to every employee and we became better listeners about understanding what are the things that are risky and what are the things that are helpful. So I want to share with you one example of our first kind of public use case of this technology. The city has over 16 years worth of votes that have been made by the city council. And if you look at this screen, the information that we used to publish on the website was just this description, the votes, and the docket number. But that summary that you see at the top in that FY24 budget adjustment for collective bargaining agreements, that's something that did not used to exist. So when a resident was trying to look through what the council had voted on, they would have to click through each of these, read this rather complicated description of what the vote was about to try to understand whether something was relevant and what had happened. So with Michael and with our digital services team, we worked on connecting our website to generate these summaries using Google's Gemini, model to create 20-word summaries that could create a better experience for the public and now enable a little bit more clarity around what was it that the council was voting on. So it's a generated summary. It costed about $4 to generate summaries for over 16 years. And again, we continue to think about how is it that we can drive those types of use cases. So just wanted to share with you briefly that this is the link to the guidelines that we've put forward. We keep learning from people that give us feedback on the guidelines. So if you have feedback and you think you've used them or you think that there's an area for improvement, please reach out. And we are in progress to build the next iteration of the guidelines. That so much has changed since we put them out that we're actively looking at building the next draft. And again, just so you know what's the content of the guidelines, and we tried to keep it very clear and very simple what we thought people should be, how they should be using generative AI. We said, foremost, everything that is generated is the authorship of a person. It is the same way that you wouldn't blame your calculator for having the wrong budget or Excel. We are saying generative AI, the models and these tools are the work product of a person. In the case, for instance, would we have the generation of the summaries, it is our work product. It's not the tool, it's us. And we need to make sure that it is accurate, that it is not biased, that it is not offensive. And it is our job to evaluate and figure out that before we put stuff forward, but it is our content. Secondly, we've made the decision to make people disclose the fact that we have generated content, again, to try to keep the trust between us and each other and the public as well. And if you go to the website, we've also, again, been innovating and trying to figure out ways in which we can make that disclosure. And again, trying to bring people along the journey and helping us make sure that as we use these tools, we could do it better in a way that promotes trust and more effective communication. And then thirdly, not using sensitive or private information in the prompt. So not using any information that wouldn't be subject to a public record, so that it wouldn't be already a public document or open data. That third guideline is the most likely to get changed now that we have access to enterprise tools and tools that have the ability of using this generative AI tools in a private enterprise setting, but that also will start forcing us to be more thoughtful around risk management. So what are the use cases? How do we document what the use cases are? And how do we make sure that we're doing right by everybody? So we'll have the new guidelines soon. Probably around like late summer or early fall. And again, we're already grateful for people that have reached out and shared their feedback around our guidelines, and it makes all the work. We're collectively all working. We're part of a community, so we value your feedback. So let us know if you have thoughts.
Great. So let's quickly review some of the tools that we're using in Boston. Around generative AI. We haven't done too much with text-to-image models like DALL-E, if you've played around with that on OpenAI's platform. But we're planning some prototypes that could help our urban designers plan public spaces. In particular, we've been experimenting with Adobe Firefly, which is available to anyone who subscribes to Adobe's Creative Suite. But most of our prototyping with generative AI involves large language models. And we've mostly been using tools from Google, like Gemini, which is what we used for the City Council roll call project that Santi mentioned. And we've also been using some of the tools from OpenAI, ChatGPT in particular. So and just so that we're on the same page, we've been reminding people that large language models don't actually understand the content that they're giving you. They're merely predicting the next word as it constructs a sentence when it tries to answer one of your questions. But this still turns out to be quite powerful, and we're really optimistic for how we can use them in the future. And we're using AI and I guess more traditional machine learning to tackle a variety of real problems and use cases in Boston. Everything from traffic congestion to streamlining trash routes, to giving us a better way to predict flooding along our coastline. But we wanted to review 3 use cases in particular, and we'll have a caveat for you all, at the end of the presentation. Our first use case revolves around translation. Some of you might know our 311 app that we launched 14 years ago, and in 2022, we updated the app and made it available in 10 additional languages. For example, here's a screenshot of our 311 app in Haitian Creole, and making it available in additional languages was a critical step in ensuring that we make 311 more equitable, since over 100,000 of our residents don't speak English as their primary language at home. I think another point is that we get close to 1,000 service requests per day, and the vast majority of those are in English. And so solving the language barrier at scale is going to be really critical for us in ensuring that we have an equitable and approachable system. And so right now, the dynamic translation that we're using in our 311 app relies on Google Translate. But we were inspired by some of the innovation happening at the city of San Jose in California. And so what they did was they built a machine learning model that was customized for Spanish and Vietnamese. And in their case, they trained the model. They trained this custom model to understand the city context. So in other words, the vocabulary that is commonly used to report and respond to service requests, everything from getting a pothole filled to fixing a sidewalk, just really basic city services. And right now we're considering our translation options. And keep in mind that we're only considering this for dynamic text through 311. We're not considering this for live interpretation at community meetings, or translating important documents that might be on our website. And so this summer we're going to test Google Translate against a somewhat new service called DeepL, which is a commercially available AI model that is solely focused on translation. We've been seeing some great feedback about DeepL, around the country, and especially in how it can translate idioms and less formal speech. And then finally, we're also thinking about following in San Jose's footsteps and trying to understand how feasible it might be for us to roll our own translation model if we end up deciding that DeepL or Google Translate isn't going to be good enough.
And if I can add just a couple of thoughts here. The first piece is, again, just as an example of a word that might be used in Boston, but not in other places. Boston's an older city. It's been around for 400 years. So taxi licenses are called hackney licenses, which is an old English term. Again, that's the kind of thing that if you did not live in Boston, you might get a little bit confused when you first encounter the word, because it's just different from what you'd find even in other cities in the US. The second piece that I would put as a piece of advice is, again, when we've been thinking about the work that we are doing with policies and guidelines and usage, the city also has a language access ordinance and a language access team. So there's been a lot of work yesterday, even late in the afternoon, we're working on coordinating to make sure that our advice and the tools that we're offering complement the work and policy that other teams are doing, so that we're enabling departments, giving clarity to departments around when should they use what tool to do what. So just something to call out that's kind of important in an ever work of trying to integrate the different policies and the different work streams.
Awesome. So now we're going to move on to our second use case, which revolves around AI and curb regulation, or also known as like curb management, mostly around how we handle parking in the city and how we handle deliveries. And so one thing that we've been doing is we're about to roll out a concept called smart loading zones with a company called Automotus. And so these are actually already getting piloted in a number of cities, like Pittsburgh in Pennsylvania. And this is kind of what they look like. It's pretty simple when you see it in real life. So this purple curb here is a smart loading zone, and here's the signage that goes along with it. But the key difference between like a smart loading zone and a typical loading zone is that you have this extra piece of technology. So if you look at the upper right-hand corner here in this diagram, that represents a camera that is essentially looking at license plates of either cars or vans that end up getting parked. So in this diagram, a camera gets installed on a pole, and then using computer vision and machine learning, it can automatically detect the type of vehicle that it's looking at. In this case, is it a car or is it a van? And it reads the license plate number to automatically charge the delivery company. And we should also note that the technology is also mindful of privacy, and it automatically blurs faces and de-identifies data. And so, one thing is, why would we roll out smart loading zones versus, a typical loading zone? It turns out, or at least we're hoping that it will have a lot of benefits. We hope the pilot here in Boston will achieve three things. We hope that it's going to make parking more available. We also hope that it's going to reduce double parked delivery trucks that end up increasing traffic congestion, especially in our downtown areas. And then third, we hope it will reduce vehicle emissions, since a lot of these delivery trucks frequently need to circle a block when they can't find a space. And then the second thing around using AI for curb management revolves around this SMART grant that we got from the U.S. Department of Transportation for digitizing our curbs, that Santi was actually able to essentially won us the grant here, wrote the grant for Boston, and I'll pass it on to him so he can sort of describe the project.
Yeah, I think that this is one where there's what's interesting is that technology has been moving so fast that in the time that we build the proposal and now the approach that we will take is substantially different thanks to the evolution of the technology. So if you should come and visit us in Boston foremost, and you should let us know so we can show you around. But when you come to Boston, you might at times be a little confused by our street signs. And generally, again, we have like traffic regulations, turn left, don't turn left, stop signs that are very standardized. But when it comes to parking, we are an older city where we've done things a little bit differently throughout different parts of time. So what you see here is just an example of like this really complex set of regulations that applies to a part of town. And not only is the regulation kind of tough, to interpret for a person in the field. Currently, in the past, haven't had information about what that regulation was in any digital format. There's no digital analog to the physical reality of what's been printed there. So it means that if we are trying to figure out if there's parking restrictions or curb restrictions that do not match what our regulations in the books are, we can't do it. If we wanted to try to understand which is the piece that we have heard from constituents, they're very interested in being able to see, where could I park when? If I am going to go visit my grandmother in Charlestown, can I park there later? So this is, again, to Michael's point, and people are right now going into Reddit and trying to figure out, asking people to see if they can help interpret the regulations. And again, a lot of these signs are not standardized, so just makes it a little bit challenging. So our initial approach was going to take, we have copying other examples of things that have worked in cities. We were going to get data that we had collected for assets through Cyclomedia that are not integrated into our new asset and work order management system, which is Cartograph. And we were going to use computer vision to extract the information from the signs, extract the text, then build some classifiers to build a new schema to try to classify what types of signs existed, and then build a model. And we were going to try to do an open source thing where we would show you guys, like how we did it, so other people could copy it. And
yeah, let's go off script just a little bit. Could you describe what Cyclomedia and Cartograph are?
Absolutely. Thank you for. So one is a contract that we had for collecting data from the right-of-way. So there's a truck that drives with high-resolution cameras and LiDAR to collect information about the different signs and the different assets. And then they're able to use machine learning to extract the different types of assets. For what it's worth, again, this is where there's other companies that are using this type of technology, and there's a local company called Civil AI that we've also partnered with to do a pilot. So regardless of whether you could do it that way, you could manually have people to go take pictures. And Cartograph, again, is a work order asset management system. So once we know that there is an asset, and we've represented it using our geospatial information system, our GIS system. So we have little dots for each pole, and each sign is a little dot, and we have other pieces of GIS data. But again, for parking restrictions, for curb restrictions, we only know that there is a sign. We don't know what the sign says, and we don't know what regulations apply, because these are signs that are under the, getting a little nerdy, with the standardized management system for signs in the US, parking restriction signs are like a second-class citizen. They just know there's something there, but there's no uniform way of standardizing what the restriction is. That was kind of the setup that we had. And again, we have people that are interested in knowing more about where could you park. And if you think about it, when we're doing, for instance, construction projects, we don't know what the impact on parking availability is for what we do in the city. So intertwined between economic development, the vitality of our businesses, the reality for our residents. And these things matter, even the very nerdy things matter quite a bit. So long story short, we're going to go and do this more of a classical machine learning approach. And stage left comes these new multimodal models, like the ChatGPT for Omni model. And this is a little exploration. Some of the best innovations come from playing around. So I was having dinner with my wife. I heard someone stopping by, we're at a patio, and someone stopped by and asked the waiter if they could park there. And both the waiter and the people that were asking for guidance were standing right next to me, and they're trying to interpret what that sign said. So, I figured, at the risk of upsetting my wife, take a picture in the middle of dinner and ask ChatGPT to see if it could interpret. And you can see the results are really remarkable. Just from a picture, there's no segmentation, there's no processing. I was able to ask a question in a way that's fairly straightforward. Could someone park there at a particular time on a particular day? And the model is able to extract the information, even when there's some obfuscation, some of the text is covered by leaves, it's able to extract the text and then perform reasoning in deciding which of the regulations applies to that particular time and give me the correct answer of when I can park. So it's just a sample size of one, but this is kind of how the new approach that we're going to take is using this multimodal models to try to develop kind of maps around parking availability. And again, this is just an example. New York City has a really great data set of inventory of all their signs and their maps, but you can even see how difficult it is. But there's great open data around the signs and the availability, but also the restrictions around how is it that we can create meaningful interfaces for the public to consume. Like in the city of Boston, we have 300,000 signs. New York City probably has in the millions of signs. How are we able to take all that complexity and all that information in a way that is meaningful and simple and consumable for someone who's just trying to have a better experience in our cities? That's the challenge at hand.
Cool. So we'll move on to the last section of our presentation, which revolves around preparing for a changing climate. We're going through a heat wave here in Boston. I think it's happening throughout the country and maybe other places in the world. So it's definitely top of mind on a day like today. But much of what we're thinking about with preparing for a changing climate revolves around water. So more floods and drought due to extreme heat. And then in a few minutes, we'll see that there's a surprising link here to AI. And so environmental planners at the city, use data and AI-enabled climate modeling to forecast potential floods well into the future. And this helps us plan how we're going to protect our neighborhoods here in Boston, especially neighborhoods that are already prone to flooding and are near the coastline. And so in partnership with the Stone Living Lab here in Boston, our planners have installed a network of sensors that monitor water levels along our coastline. We can use this data to improve short-term flood forecasts with AI and create an early warning system so that we're more prepared for flood emergencies. And by the way, these sensors are from a company in Hawaii called Hohonu. So if you're interested in checking that out, we can send a link over. And so kind of the flip side to this. So AI, we definitely think AI and machine learning can help us, prepare for a changing climate, but there is also the environmental impact of using AI. And so, this is a data center which stores and processes enormous amounts of data, much of it available on the internet, like your favorite videos. And the AI models that form the basis of services like ChatGPT get trained in data centers. And the computer systems creating these models perform a staggering number of calculations, trillions per second. And these systems consume a lot of power, give off a lot of heat, and need to be constantly cooled down in order to function properly. So how do the managers of these data centers keep their data centers cool? Essentially companies like Google use an intricate system of pipes and coils to run cool water through their facility. And when the water flows towards areas with hot equipment, the heat from the air transfers to the water, which is then carried to a cooling tower on top of the data center. And you can, in this image, you can see the little steam clouds, kind of chilling, above the data center. And, this kind of boils down to a question, which is, why would we care about this, and what's the connection to climate change? The answer is that, climate change is going to cause more droughts, and some data centers use close to 500,000 gallons of water a day and could add significant stress to local water systems. And here's a map of current drought conditions across the United States. The areas in red are dry, and the areas in blue are wet. And we can take New England, in the upper right-hand corner here as an example, where we are. And we're looking okay, this month as of June 10th of this year, but that wasn't always the case. This is how things looked a couple years ago when we saw extreme drought conditions here in New England. And it's just a reminder that even areas that haven't typically experienced too much trouble with droughts are not immune to this issue. And we'll need to keep an eye out for new use cases for water, like the expansion of these data centers throughout the world. So just to wrap up, we have a couple of wrap up points that we wanted to kind of review with you all. So Santi, do you want to take the slide?
Sure.
Yeah.
I'll just wrap up quickly so you guys, we can talk about some of the questions you might have. But again, some of the pieces that we've been working on actively is how can we leverage, and again, there's a set of tools, some that are commercially available, some others that are freely available. Usually you contribute to the training of the model if the tool's free. But using retrieval augmented generation, this is the type of technique, if you've seen custom GPTs, if you've seen, a lot of times when people are saying we're training the model, what they're doing is enabling the reference of specific documents or specific content through this set of techniques called retrieval augmented generation. So we've been looking at how is it that we could use some of these tools in an enterprise setting to enable public servants to get information. Most of what we do involves getting information from a number of different complex sets, like the short handbook for procurement in Massachusetts is 200 pages. So yeah, everything that we do has like a short handbook of, and I know like in South Bend, Indiana, Denise and the team is using this kind of tools to help people navigate policies. But so that's a set of things that we're doing. And again, like we're trying to figure out what is the right set of tools to enable enterprise access to these like retrieval augmented generation tools. Secondly, again, we keep thinking about this data privacy in LLMs, particularly as we start thinking about integrating LLMs or multimodal models, large language models or multimodal models in data engineering pipelines, like as part of a process like what we described in the curb management system or in our translations, in our summaries of the website. There, what we're doing is working with, right now, most of the way that we can access these services in a safe, secure way, and also viably through our procurement code, is leveraging the APIs, the application programming interfaces that we can get through Amazon Web Services or through Azure, through Microsoft, or through Google. And there, what we can ensure is that the terms and conditions and the technical solutions, we are not passing, whenever we use these LLMs or multimodal models, we're not actually passing information back to a human being or to the company to review. It just allows us to run the inference. So that's just kind of the pattern that we've been using. And again, all of these are the types of things that we know that need to be reflected in our next iteration of the guidelines. And again, we keep also working, lastly, like on these like small language models and ways in which we can figure out if we can get better performance out of tuned models, like truly like changing the nature of the model, whether it's for improving the accuracy of translation to make sure that it reflects the Boston specific language. But another piece is, again, going back to language access, the city has 10 official languages. And we know that for some of those languages, there's actually very little training data compared to the corpus of like what English or Spanish or even Portuguese might be. So Haitian Creole, Cape Verdean Creole. They're languages that have less text, and we want to make sure that the translations and the experience for people using those languages is equally good and dignified and whatnot. So we keep looking at when and how, like there's a set of, this is a space that changes really rapidly, but again, like how can we make sure that we're giving consistent high quality experience for people that don't speak English, might not even speak some of the other major languages that are spoken in the city of Boston.
Great. And then later this year, we have a few things, a few resources that might be of interest to you all. So for the past few months, we've been working with Professor Sarah Williams over at the MIT Media Lab on, we did a series of workshops with her group to sort of figure out ways that we could use generative AI in community meeting settings. And we're going to have a new paper coming out pretty soon, probably in the next month or so. And we can send that around. Earlier Santi had mentioned, we're going to have version 2 of our generative AI guidelines that should be coming out this fall. And then this summer, I'm working on a variety of prototypes that will have, the source code will be publicly available on GitHub. And this is through a partnership with, we basically have some open source contributors that are getting funded through a program called Google Summer of Code. And so that's how we're able to, build out some of these prototypes this summer. So happy to, share that code on our GitHub accounts. And that's pretty much all we had today. I see sort of a number of questions in the Q&A here that we can go through, and, thanks for listening.
Yes, so let's go ahead and just dive into some of these questions that we've been asked. So a couple ones here is, I think you touched on this a little bit, but it was, is there a catch-22 with AI and climate change based on the extreme amount of energy it's going to need and where those energy sources are going to come from?
So I can take that question. So it is, again, part of the competing priorities and the kind of the difficult trade-offs that we're doing. We are working in the Commonwealth of Massachusetts at the state level with some of the leaders at the state level and thinking about how is it that we can enable infrastructure that is, so data centers and whatnot that are powered by green sustainable sources and that are more efficient in the water use is something that we've been working on. And again, we broadly think about this also in the context, not only about generative AI, but generally our environmental footprint and everything that we do around PC management, servers, and all this stuff. So we just want it to be clear, like it's not trivial, it's an important issue, and there are trade-offs. Like the same as we use trash trucks and other pieces of equipment that might be fairly polluting, but we're not dismissing the fact that these are environmental intensive technologies that we have to be thought the costs and the impacts. But that's partners and with vendors to try to figure out ways of mitigating that.
Somebody had a question about the example you talked about with the city council roll call project, and they said, what was the reason for choosing Gemini versus using OpenAI?
So one piece of advice and something that we've been doing is like trying different models for different things sometimes allows us to expose and understand the difference in performance. One thing that I would tell you about this particular example is we did the evaluation. When we first developed the first prototype was built on Gemini 1, and we noticed substantial improvements in performance of Gemini 1.5. So we're trying different models and we're trying to compare the performance. Why Gemini 1? We were able to send part of our team to do an enablement that Google, they offered to do a day of training for our team. And so the first thing that they tried was the Google tools, because we are we have a partnership. We work with most of the major kind of cloud providers, but it's just a little bit of serendipity. But then the piece of advice that trying different tools, and the tools change from version to version, so it's worth sometimes that something that might not have worked in the first version might perform much better in another version.
Right. Yeah. I mean, I probably would have expected similar results between, you know, the latest Gemini and the latest GPT. So I don't know if there's, you know, much of a difference there. And, you know, in this particular case, we use Gemini. But, you know, we're trying both Gemini and OpenAI, or Google and Open models.
And there's differences in cost to run the tool. So Claude is cheaper than the Claude, which is a model that you can get through Amazon Web Services, is much cheaper. And then depending on the size of the model, but again, it's the only way of knowing these things is like experimenting and trying to figure out how things perform in different environments. And that's the approach that we've been taking.
And I think this kind of goes into the next question, is just, you know, more specific examples of improvement of the 311 app for translation over Google Translate. So you kind of talked about like what's working best for you. So can you dive in a little bit on how you are seeing improvements of that 301 example?
Oh, well, so this is still early days for it in Boston. So that's a lot of the work that we're going to be doing this summer, which is kind of this testing of, you know, other services like DeepL. You know, just to kind of reference the improvements that they saw in San Jose, you know, when they tested this with, you know, native speakers, with their custom translation model, you know, they were seeing, you know, anywhere between like a 20 to 50% improvement in what they were calling like an acceptable translation. And so, you know, they found that the custom model, you know, worked, you know, really well for them. I think what we'll, you know, one of our first steps here is, you know, if we were going to compare, you know, what's possible with Google Translate versus something like DeepL, you know, how do people, you know, in our communities actually, you know, feel about the comparison in translations, and, you know, do they think one is better than the other? We still don't know quite yet. It's just that we have a hunch that there might be some improvement with DeepL just based on some feedback that we've heard. So
I'd give an example. Not large statistical validly, but you know, when we're preparing for this presentation, we're translating the example of the excerpt that we shared with you. Talks about a shift in funding in the budget to the property management department. When we use Google Translate, it describes that as Departamento de Propiedad Administrativa. That makes no sense. It's Departamento de Administración de Propiedades. And an LLM provides the correct translation, whereas Google and they're both using machine learning. It's just one is a more sophisticated, bigger model that's a little bit more expensive to run. So it's just, those are the types of things that we notice when we use the LLMs, that it does a little bit better job of catching. But we are, to Michael's point, we're working, this is going to be active work of development and trying to figure out when we can use it. And again, we've been putting everything that we do, we're doing testing and then evaluation. Hopefully we can share more about what we're doing to test and evaluate these tools, regardless of whether we're building the tools or building something and just getting a component through an API or buying a tool. We think that you have to evaluate and not only rely on like what the contract says, but figure out, and especially if you can put the use case in the context of what a user would expect. Like, what does a person that doesn't speak English experience? That's the bar that we need to clear.
Great. Well, we have a question here. It says, from their city, we have a way for people to remove their name from our property appraisal database. Often politicians and judges and people that have unwanted attention will remove their names and will scrub that in our open data. Boston is doing great work on data privacy, but I am curious if you have thought about removing names from existing LLMs.
So my quick, give you a specific example and then like more of a philosophical point. So the specific example is we constantly have, literally this week, we're having some conversations around the trade-off between transparency and privacy. We are required by law in a lot of cases to provide, like information about public employees, their names, their salaries. So it is pieces where there's like a trade-off between navigating the trade-off, and a lot of times there's going back to the lawyers to figure out what the actual legal obligation is, and then figure out if we're going to make a change that it's consistent across the board, so that you don't want to be exposing someone's information in one system and then trying to protect them in a different system, because it just negates. One piece around large language models is the more philosophical point. A lot of these models are closed source. We don't know. We generally have a sense of what type of data they've been using to train the models, but we don't always know. And that's an area of risk, and an area where we have heard from community members that there's a lot of concerns. One, we don't know if that some of these companies have been using copyrighted material. We believe that they have been using copyrighted material. And that obviously from an ethical perspective, and also from social policy perspective, we want to encourage artists and people that tend to, writers, graphic designers, people that tend to be very vulnerable from an economic income stability standpoint. That's against our values, and and secondly, again, there might be information that is sensitive, personal identifiable information that might have been in the original data sets, and we can't change it. Once the model's been trained, tuning and changing the model is extremely hard, and in a lot of cases with the commercial models, you can't. So that's an area that we collectively need to keep paying attention. And I think that the more that we can advocate for open source models that are more ethically built, where we know what data was used to train, what data was used to test the models, the better we will all be off.
Right, thank you. We do have we're at the 5-minute mark, so I would like to save time just for this one question that I think is going to be great for maybe for our smaller cities is, do you have any tips for smaller communities that are at the early stages of exploring AI, ML-based solutions with consultants and partners, especially as related to the use of data?
I have some advices, and again, we work very closely with other Massachusetts municipalities, with the Massachusetts Municipal Association, and with other cities. I'll tell you, smaller cities often can do more innovative, more interesting things faster than we can. So a lot of love and hope for smaller cities. I would say, one, leaning into your expertise. I think that what the output should look like. What the outcome should be. So not letting the vendors intimidate you. I think, two, just because something uses AI doesn't mean that it is better than the thing that doesn't use AI. And that is a decision that you go back to the user, go back to yourself as a consumer of the tool, what makes the most sense. And that being said, I think that a lot of these tools are fairly affordable to be able to enable people in smaller communities that have less resources to do things that wouldn't be possible. Like if you don't have a graphic designer, you could use some of these tools to help design graphics and stuff. If you don't have the funding, or you don't have the infrastructure to support a data analytics team, you can use some of these tools to do data analysis. It's a little bit riskier, as in you might not be able to have an in-house expert that is able to tell you about whether the generated product is of higher quality. But I think that sometimes the reality for people in a smaller community is not about, it's nothing or something that's a little, like you're having to make a tough trade-off. But people in small communities are used to making tough decisions. So I think that's just, but if you ground it into, don't let the vendors intimidate you, or just because something uses AI, as long as it makes sense to you and makes sense to your constituents, that's, I think, the bar.
Yeah, I think one thing that I've been a little excited about, I don't know if Brendan from Anchorage is still here. Is he still here? Okay, yeah. So he had posted something that I thought was interesting, was just the ability to share custom GPTs on the OpenAI platform. And I don't mean to sort of like vouch for OpenAI or anything, but basically there are a lot of people who are, building these fairly accessible tools to help with, help with data analysis or help, write a SQL query or something like that. And I think in the past, like maybe month or so, it's gotten a lot easier for people on the free tier of GPT to be able to kind of share these custom chatbots. And if I was in a smaller city, I would definitely take advantage of that, and just constantly talk to folks in other cities and other towns just to see what they're building, and just kind of like share share that amongst yourselves. So
Well, that's some great advice, I think, for everybody, not just for small cities, but also for the large ones as well. And we just want to thank you for your time, Michael, Santi, for sharing your knowledge, also your experiences of what you've been doing with AI in Boston. And just so we all are sharing here, we have a survey that we would love for you all to fill out, just experience with it. And also we'll be sharing this recording and the presentations on the community forum. So, if you need to go back and reference things, you can reach out to Santi and Michael as well. And, keep the conversations going, because AI is not going anywhere, and it's just gonna, seeing it as a tool and not the enemy, right? That it can really help make things more efficient in our cities, in our communities, and just in the daily work that we're trying to achieve, right? So thank you guys so much. And we really appreciate you taking the time to share with us today. So thank you, and have a great rest of your day.
Absolutely. Ciao, gracias.
bye.